Now here the question is, 3 6-faced square die are thrown together. Let pk denote the probability that sum of numbers appearing on dice is k, and if this summation k varies from 9 to 14 pk, then find the value of 54s minus 30. Now suppose number on first die is x1, number on second die is x2, and number on third die is x3, and it must be equal to k, where each of xi it can take the value from 1 to 6. Now since for each x we have a minimum and a maximum, so what we'll do is we'll solve this question using binomial theorem. So that means we have to find coefficient of x to the power k in the expansion of x plus x square up to x6, and since we have 3 dice, so it will be this power 3. Now we can take x cube common, so basically we can write, we have to find coefficient of x to the power k minus 3 in the expansion of 1 plus x square up to x to the power 5 to the power 3, or we can write coefficient of x to the power k minus 3 in the expansion of 1 minus x to the power 6 upon 1 minus x whole cube, which is coefficient of x to the power k minus 3 in 1 minus x to the power 6 to the power 3 into 1 minus x to the power minus 3. Now value of k, it lies from 9 to 14. Now k minus 3 is 6 up to 11. So this power, it goes from 6 to 11. So we can write this as, we need to find coefficient of x to the power k minus 3 in 1 minus 3x to the power 6, and we'll discard higher powers into 1 minus x to the power minus 3. Now we know that coefficient of x to the power r in the expansion of 1 minus x to the power minus 3 will be n plus r minus 1 cr. So there will be 3 plus r minus 1 cr, or we can write this as r plus 2 c2. So it will be this coefficient of x to the power k minus 3 in 1 minus 3 into x to the power 6, and then this binomial summation of r plus 2 c2 x to the power r. Now we get coefficient of x to the power k minus 3 if we take r as k minus 3. So it will be this k minus 3 plus 2 c2 and then minus 3 into now x to the power 6 into x minus r. So it will be coefficient of k minus 9. So there will be k minus 9 plus 2 c2. So sum of the numbers will be k in k minus 1 c2 minus 3 into k minus 7 c2 ways. Now we need to find this probability that this sum is k. So this probability will be given by k minus 1 c2 minus 3 into k minus 7 c2 divided by total choices, and that will be 6 into 6 into 6, and that is 216. Now we need to find this s, which is this summation k varies from 9 to 14 pk, and which will be this summation k minus 1 c2 where k varies from 9 to 14 minus 3 times this summation k varies from 9 to 14 k minus 7 c2 divided by 216. Now we need to solve these two summations. Now if we look at this summation, which is summation k minus 1 C2, where k varies from 9 to 14, basically it will be this 8 C2 plus 9 C2 up to 13 C2. Now what we'll do is we'll add 8 C3 and we'll subtract 8 C3. Now and same r differs by 1, so it'll be this 9 C3, again 9 C2 plus 9 C3, it'll be 10 C3, and finally it'll be 13 C2 plus 13 C3, and that'll be 14 C3. So this value will be 14 C3 minus 8 C3. And if we look at the second series, which is this summation, k varies from 9 to 14, k minus 7 C2. Now this is 2 C2 plus 3 C2 up to 7 C2. Now 2 C2 is 1. We can also write this as 3 C3. So next one will be 4 C3, and finally it will be 8 C3. So this first summation is 14 C3 minus 8 C3, and this second summation is 8 C3. Now we put the values of these summation, then we can write this S as 14 C3 minus 8 C3 and minus 3 8 C3. So that will be 4 into 8 C3 divided by 216. Now 14 C3 is 14 into 13 into 12, and this is 6 minus 4. Now this is 8, 7, 6, and this is 6 divided by 216. Now this is 2 and this is 6. So it will be this 28 into 13 minus 8. 13 minus 8 is 5 divided by 216. Now this is 7, 54. So it will be this 35 by 54. So value of S is 35 by 54. Now we need to find the value of 54S minus 30. Now 54S minus 30, and there will be 35 minus 30, which is simply 5. So answer to this question is